Anatomy of a computer. Hardware components. Computer hardware is the physical part of a computer, as distinguished from the computer software that executes or runs on the hardware. The hardware of a computer is infrequently changed, while software and data are modified frequently. The term soft refers to readily created, modified, or erased. These are unlike the physical components within the computer, which are hard. When you think of the term computer hardware, you probably think of the guts inside your personal computer at home or the one in your classroom. However, computer hardware does not specifically refer to personal computers. Instead, it's found in all types of computer systems. Computer hardware is an embedded system in automobiles, microwave ovens, MP3 players, smartphones, and many other devices. Motherboard. It's like the central nervous system for the computer, through which all other components interface. It's the central circuit board making up a complex electronic system. A motherboard provides the electrical connections by which the other components of the system communicate. The motherboard includes many components, such as the central processing unit, also known as the CPU, random access memory, RAM, firmware, and internal and external data buses, which are like highways for data to travel. It also has slots for expansion cards to expand memory or processing power of the CPU. Central Processing Unit, CPU. It's sometimes just called a processor. It's sometimes referred to as the brain of the computer. Its purpose is to execute computer programs. There are 4 steps that nearly all CPUs use in their operation: fetch, decode, execute, and write back. The first step, fetch, involves retrieving an instruction from program memory. In the decode step, the instruction is translated for the CPU so it can understand it. During the execute step, various portions of the CPU, such as the arithmetic logic unit, ALU, and the floating point unit, FPU, are connected so they can perform the desired operation. The final step, write back, simply writes back the results of the executed step to some form of memory. Random access memory, RAM. Usually referred to as memory, RAM is second only to the CPU in determining a computer's speed and performance. It temporarily stores a computer's activities until they're transferred and stored permanently onto a hard disk. RAM is like a computer's personal scratch pad that's used while it's working hard for you. RAM attaches directly to the motherboard and is used to store programs that are currently running and its related data. RAM is a set of integrated circuits that allow the stored information to be accessed in any order. That's why it's called random. There are many different types of RAM. Distinctions between these types include writable versus read-only, ROM, static versus dynamic, and volatile versus non-volatile. The power supply. The power supply, as its name might suggest, is the device that supplies power to all the components in the computer. Its case holds a transformer, voltage control, and usually a cooling fan. The power supply converts about 100 to 120 volts of AC power to low voltage DC power for the internal components to use. It turns the computer on and off and supports standby mode. Removable media devices. If you're regularly putting something into your computer and taking it out, it's most likely a form of removable media. There are many different removable media devices. The most popular are probably CDs and DVDs, which most computers support. Other popular removable media include USB memory sticks, SD cards, and portable hard drives. All of them serve as methods to store and retrieve data and programs. Internal storage. It's the hardware that keeps data inside the computer for later use and remains persistent even when the computer has no power. There are a few types of internal storage. Hard disk drives, HDD, are the most popular type of internal storage. Solid-state drives, SSD, have grown in popularity slowly. Storage controllers. They control internal storage and removable media devices like hard disk drives, solid-state drives, CD-ROM, and other drives. The controllers sit directly on the motherboard, onboard, or on expansion cards. A graphics controller. It produces the output for the monitor to display. The graphics controller is a chip also known as a graphics processing unit, GPU, or a video card. The graphics controller processes the graphics received by the computer and creates the dots and lines on the screen to generate the picture. Sound card. A sound card, also referred to as an audio card, is a peripheral device that attaches to a slot on the motherboard to enable the computer to input, process, and deliver sound. Input and output devices. An input is data that computers receives. An output is data that a computer sends. Computers only work with digital information. Digital information is represented as zeros and ones, or off and on states. Any input that a computer receives must be digitized. Often data has to be converted back to an analog format when it's required for output. For example, the sound from a computer's speakers. An input device converts incoming data and instructions into a pattern of electrical signals in binary code, zeros and ones, that are comprehensible to a digital computer. An output device reverses the process, translating the digitized signals into a form intelligible to the user. Input devices include keyboards, scanners, handheld devices such as the mouse, trackball, joystick, and microphones. Output devices include display screens, inkjet and laser printers, loudspeakers, and devices such as flow valves that control machinery. Interface controllers. Interface controllers are used to connect the computer to external peripheral devices such as printers or scanners. There are two ways of transmitting data between two digital devices. We can either transmit the data in parallel, where we transmit multiple bits of data at a time, or we can transmit the data in serial form, where we transmit one bit at a time. The following illustrates the differences between these two types of communication mechanisms. In parallel mode, each bit of data has a single wire devoted to it, and all the bits are transmitted at the same time. In serial mode, each bit is transmitted as a series of pulses over a single wire. Examples of serial interfaces are USB and FireWire.
Examples of parallel interfaces are SCSI.